Hey everyone, Blake here. So today I'm going to walk through some of the research I've done on the question of document accessibility. PDFs have come under criticism for not being an accessible medium. Some of the critiques are that they do not work well on mobile. They're not great for data exploration. They're not interactive. And all of these factors mean that PDFs are not great. They inhibit people from reading research papers. It's so painful to read a PDF on your phone and constantly need to switch columns and do, all of that rigmarole just to get the data out of the paper and into your mind. Furthermore, scientific papers as a whole don't necessarily have the best practices when it comes to accessibility in terms of color. So this is the ideal case where there is color information, but there is additional information so that even when you're looking on black and white, like Kindle document, you can still make out what the individual categories are in your bar plot or similar. Okay, great. I'm going to start with this plot and then show you that I can convert into something more accessible, even though I don't have the source code. And in general, I'm going to talk today about what we can do when we don't have the source code in the document, but we want to restore some of the semantic markup. So I'm taking this and I'm just taking a screenshot here. And then I move over to Inkscape. You see I've already done some work here. This is my replication of that work above. So I'm going to paste it, just shrink it, make it manageable. And then I'm going to click this trace bitmap function. In the multicolor tab, I'm going to use these settings, which I set from before. And when I click apply, it's going to create a very close to perfect recreation of the above document. Yeah. And this is great because you can see how when I hover, the colors are already highlighted. So it looks like the way Inkscape does it preserves some semantics. We might possibly lose those semantics, but even still, these are all the same color. So we know we can select them. When we have this here, we can actually replace this with a pattern like that. And then do the same thing for this one. And we can select arbitrary patterns as long as they're distinct. And I don't think this is the most clear one we could do. Maybe something like this could be better. Yeah. Just adding these textures. And then we'll go back and add a stroke to everything as well. But again, I'm just going through showing that it can be done. So it's kind of a proof by example case. Okay. So we took something that wasn't accessible and we didn't actually have the markup, and yet we still made it accessible. That's great. If we can do this in general, we can solve the problem of accessibility for bar plots and plots like them. We're not done. We still have to do all of these like lines. So let's say you had a bunch of like a scatter plot. It would still be difficult because if you have a scatter plot, you would need to find all of these, identify that they're circles, and then replace them with like a different shape or similar. So that could be a little bit more challenging. Also, if we have a line plot, that might also be a challenge because, again, we need to infer the semantics of the line and then convert it from a solid line to dashed line. Or if it is a line and it's thick enough, we could still employ the same trick that we are using here, but it's possible that we'll need to use a very fine pattern so that it's still visible at the end of the day. I think that's pretty clear. I think it's clear what I'm saying. So we can also add some stroke paint. This is possibly optional in the strictest sense, but I think doing so makes everything just that more visible, more. Yeah. these are not great. It's something we'd probably need to work on. So to work on that, we probably take the trace bitmap functionality and then figure out how to smooth corners and optimize so that in the ideal case, we wouldn't have this kind of negative user experience here of reading this kind of garbled text. It may still be better, but if we aim really high, we want to have like a very close to ideal user experience. Yeah. So, good. So that takes care of plots. Tables are actually fairly elegant because going to here, there's this meta AI research paper called NuGet. And NuGet actually has these tables that are correctly transcribed by the document, which I think is fairly impressive. This is great because it means that if we have something that will partition a research paper into tables and figures, we can apply the same rules that we've established so far and then make the entire document accessible as a whole. So that means reflowing all of this kind of text. That means making this work for a mobile device so you don't have to scroll left and right or manage the dual column problems of the PDFs. And then that's great because it means all of the research is a little bit more accessible, even if we don't have the source code. If we have the source code, in principle, there are going to be better ways to convert the source code into semantic markup. I can think of many ways where you could use, there's this project called R5, where they convert from tech with this tool called tractability. This could be a route forward when we do have the LaTeX source code. If we don't, or if I've actually used this, and I can confirm that there are some papers that fail outright. So as a fallback, we could use a system like the one I'm describing. Okay, good. So where does that leave us overall? We suppose that we can transcribe text, tables, and we can handle plots. What about the document flow overall? Well, we could use NuGet for that, but the limitation is that NuGet skips over figures. So if you look here, this figure 5, isn't showing up, and it doesn't have a way to, it doesn't transcribe this figure. This is a problem, but we have a solution. Using this GitHub repo called layout parser, we can take an image of a paper altogether and break it up into these components and then independently transcribe each of those components, which is great. So this is tractable. So that's how you handle the document overall. We would use NuGet as the OCR agent because it will also handle tables and not just text. There is other semantic information, such as footnotes and references that might not be handled. For example, one I saw under NuGet is one of these examples has these labels that are not honored by the transcription of NuGet. So that would be another point where a system like this could get an additional push. But I hope I've shown that it's actually tractable so far. Now I'm going to dive back in and I'm going to talk about what the ideal case is, because I think in this case we got lucky that the automatic tracing of this was so good, right? I had to do almost nothing. It even grouped the colors together. But what if we're not so lucky? I'm thinking there is a system where we can take the image, convert it into R, G, and B, and then perform some operation to convert. Actually, I think the proper way to annotate this would be like this. Let me clean this up. I'm converting each of them independently into SVG and then combining them into like that. Okay. And this might be more robust because if we don't get lucky, we'll have to handle the color partitioning ourselves. That would be bad. I'm anticipating that would be a pretty negative experience because you have to use some sort of bucketing to find the number of colors, or you could partition the space into a bunch of contiguous regions and then count the colors in those regions and then drop because every document has a long tail of a bunch of unique colors. If you find the mode colors in a document, those would be good candidates to select for when you're converting to an SVG. But I have my suspicions that a more robust system could handle that situation implicitly. And I'll explain some of my reasoning and how I might solve it myself. What I would do is, so the thing you saw me do was image, then split, then make accessible. And make accessible here is by converting it into SVG and then using a texture instead of a color as the fill for that SVG element. Okay, good. But, so this is what you saw me do. What I'm wondering would be more robust is if we convert the images, split them by color, and then combine. This is just pseudocode. It's not meant to be taken too literally, but the idea is we take the image, we split by color, then we make it accessible. It looks like these are saying the same thing. Let me correct that. We split, I guess the splits are different in this case. This is semantic split, and then this is the color split. Okay, there we go. Let's make some space in the document. Make this a little bit nicer. Okay, good. So we take the image, we split it by color, we make it accessible by color, and then we recombine it. How that would look roughly is, I don't know I can do it right here, but I think it's actually more tractable to program it. Because what I'm going to say is we designate different subtextures to different independent colors. So this will be like the red subtexture. Let me grab this. This will be the red subtexture. This will be the green subtexture. And then the blue one could be triangles. We're choosing these shapes because they're distinct, and I'm trying to create some notion of like orthogonality within this. Because if they're orthogonal, then we can compose them into unique sub-elements. We would also need to ensure that they have the same kind of lattice structure. So I think what we have here is perfectly fine because these can compose. So this would be red compose green, and then green compose blue would be this. And yes, I'm going to widen it, but in theory, they have the exact same dimension, so I wouldn't even have to handle it that way. Okay. Yeah, so it doesn't look great, but that's just because the layout is a bit funky. But you can take the impression that each of these is an identifiable subpattern, so that we break this up into the red, green, and blue channels, and we fill it with these sub-elements at different lightnesses proportional to the color using a halftone-like algorithm and proportional to the saturation of the color. And then we can compose them. So this is red, compose green. This is green, compose blue. And then finally, we would take all of them and then compose them together for red, compose green, compose blue. So we would do something like this. But we would need some way of offsetting it so that it overlaps minimally, or it overlaps in a good, predictable way. Something like this. And this can be the subtexture. That will define textures for all unique colors that might ever appear in the document. So as long as the colors are distinct, we'll be able to figure them out and annotate them and add that color information back in by converting it to a texture. Okay, good. So that's like compositionality of color. And frankly, that's like a conjecture. I don't know if this will work. I haven't tried it on anything myself besides this little example. I think there's a way to do it where it would add back in the color information to the document. That's all I know for now. I'm going to see. If there's ever an innovation, if there's an idea in this whole video that I think I came up with originally, I don't think I've seen anyone come up with such an algorithm. If it works, that would be great. Because, again, it would be such a good way to add color back into the fray. So that, let's say you have a Kindle, you can quote unquote see color on your Kindle. Good. Yeah. I did say the intensity of the color, the opacity would be proportional to the intensity of the color, or the saturation. It might be that size is proportional. I'm not sure. Because I think halftone plays with size, not the halftone algorithm plays with size for sure. Whether it does intensity or saturation or opacity as well, I'm not sure. Yeah, I don't think it necessarily. I think the opacity is just an illusion. Okay, so if we halftone it with different colors and then compose the colors, it might create unique textures, which would be unique for all of the unique colors. That's the point I'm making. Good. And now I'm just going to go through all my tabs just to make sure I capture all of that, all of the URLs. So this I already visited. This is a task on Papers with Code. This is one of the routes that you would go through if you're looking for implementations of research papers. This is just the Wikipedia page. This is very interesting because this is like vaguely what I'm trying to accomplish, but from a completely different direction. Good. A lot of people have articles of various levels of clickbait, but I think the case is strong that PDFs are very limited. Again, we have a critique of PDFs. Again, another critique of PDFs. Again, another critique of PDFs. And this is talking about accessibility in spite of using PDFs. I also remark that in a situation like this, you could use unique fonts for each of these. There are other ways to add like semantics to this kind of a figure. in this case, they're talking about alt text. So what I'm saying doesn't necessarily apply. This can be interpreted, roughly speaking, as a table because the alt text will explain the table. This is where we started. This is how they chose to do it. They chose to do it in a nicer way than I think I did. It's possible I use, instead of these shapes, I use stripes of different orientations. So we could use vertical for red, and red shading would look like this, and green would be like this, and blue would be like this. So red compose with, we could do the same thing again. And we're just showing that you can take the individual parts, put them together, and they're like still separable under the hood. This isn't a great demonstration of that, but you can still, I think you get the underlying message. It would have to be a lot more fine than that. And I don't want them to be semi-opaque. I would want them to be fully, yeah. So I wouldn't use this. I would just use the path tool. So just to show that it's possible, let me see if I could pull that together right now. It's still a little bit different. Maybe you could figure out something else, but I think the message has come across. Okay. These points are, scatter plots are going to be challenging for sure. Like I said, we'll need to take each of the elements of the scatter plot, identify it by its color, and then replace this point with a different point of a different shape. Or shade it with a very, very fine texture that is able to be resolved even with the small size of that scatter plot. Yeah, and lines will need to be identified and shaded as well, unless we could get a very fine texture version of this. Good. And that concludes the video, more or less. So that was a system design presentation of how I would design a system to make documents today more accessible, even if we don't have their source code. With all that said, thank you for listening, and I hope you have a wonderful rest of your day. Take care.